In this second outcome, we turn from the hardware to the software, the programs and instructions that actually bring a machine to life. We will look at the different kinds of software you meet at home and at work, and compare two very different ways of telling a computer what to do. So, if hardware is the body, software is what gives it purpose. Software is simply the set of programs and instructions that tell the hardware what to do. And it splits into two broad families: system software that runs the machine itself, and application software that does the tasks you actually care about. Without it, even the most powerful computer just sits there, an expensive paperweight. The software is what wakes it up. Let us sort software into its two camps. System software includes the operating system, the utilities and the firmware, the behind-the-scenes stuff that keeps the machine ticking. Application software is the visible stuff, the general purpose, specialist and bespoke programs you open to get work done. Sitting in the middle is the operating system, acting as a bridge between the raw hardware and the applications, while utilities quietly keep everything healthy. Operating systems come in a few flavors depending on the job. A single-user system serves one person, like the Windows or Mac OS laptop on your desk. A multi-user system lets many people share one machine at once. Think of a Linux server humming away for a whole office. A real-time system has to respond within strict time limits, such as the software controlling a car engine or a medical device. And a mobile operating system, like Android or iOS, is designed for touch and low power on phones and tablets. What is the operating system actually doing all day? Quite a lot, as it happens. It manages the processor, deciding which program runs and when. It manages memory, giving each program its own space and stopping them from treading on each other. And it looks after files and devices through drivers, while providing the interface you interact with. It is the same story whether it is Windows and Mac OS on a desktop, Android and iOS on a phone, or Linux on a server. Utilities are the little housekeeping tools that keep a system in good shape. Security tools like antivirus, anti-malware, and firewalls guard against attacks and unwanted visitors. Device drivers are small programs that let the operating system chat to your hardware, say a printer or a graphics card. And disk tools, things like defragmentation, formatting, and cleanup utilities, keep your storage organized and running smoothly. Application software is where the real work happens, and it comes in three types. General-purpose apps are used by lots of people for lots of things, like Microsoft Word, Excel, or a web browser. Specialist software is built for one field, such as AutoCAD for design or Sage for accounts. And bespoke software is custom-written for a single organization's exact needs, like a bank's own booking system. Sitting quietly underneath is firmware, the built-in code inside a router or a printer. The software you rely on shifts quite a bit between home and work. At home, it is browsing, email and streaming, a bit of Word or Google Docs for study, photos, games, social media, and some basic antivirus. In business, the scale changes. Whole teams share productivity suites like Microsoft 365, run specialist and bespoke systems for accounts, stock or customer records, and lean on shared servers, databases, and cloud services, all wrapped in managed security, backups, and user accounts. When you choose software, one big question is the license. Proprietary software is paid for and its source code is locked away, like Microsoft Windows or Adobe Photoshop. Open source software is free to use, and its code can be viewed and even changed, like Linux, LibreOffice, or GIMP. Which you pick depends on cost, compatibility, features, file formats, reliability, security, and support. So a charity on a tight budget might reach for LibreOffice, while a firm needing perfect compatibility pays for Microsoft 365. Let us set proprietary and open source side by side. On cost, proprietary is usually paid for per license, whereas open source is generally free to obtain. On the source code, proprietary keeps it closed so you cannot change it, while open source lets you view and modify it. Support tends to come from the vendor for proprietary software and from a community or paid third party for open source. Think Windows, Photoshop, and Sage on one side, Linux, LibreOffice, and GIMP on the other. Here is how that plays out in real life. A charity with 10 staff needs to kit out its office computers on a small budget. Some staff need Windows for a specialist grants package, so it stays on their machines, but others run Linux to save on license fees. For everyday documents and spreadsheets, LibreOffice does the job at no cost and happily opens Microsoft files, and free antivirus with a firewall and automatic updates keeps the data safe cheaply. The judgment here is a sensible mix, open source to cut costs, but Windows kept exactly where a key application demands it. More and more software has floated up off the desktop. A great deal of it now runs as apps on mobile devices, downloaded from stores like Google Play and the App Store. Then there is software as a service, which runs in the cloud straight through your browser, like Google Workspace or the online version of Microsoft 365. The lovely thing is it updates itself automatically and follows you to any device with internet, though the trade-off is that you are relying on a solid connection and trusting the provider with your data. A quiet but important skill is managing your files well. Operating systems store your work in files and folders, and good organization is the difference between finding something instantly and hunting for an hour. The file format decides which program can open a file, so .docx belongs to Word, .pdef to documents, .jpg to images. Open standards like PDF and CSV are especially handy because so many programs can read them, and keeping software upgraded with enough storage-free and unused programs removed keeps everything stable and quick. Now to two very different ways of bossing a computer around. A command line interface, or CLI, is driven by typing text commands like the Windows command prompt, PowerShell, or the Linux terminal. A graphical user interface, the GUI, is driven by pointing and clicking on icons, windows, and menus. The same job, say copying a file, can be done in either one. Most of us meet the graphical interface first, while power users and administrators often swear by the command line. Each interface has real strengths and real weaknesses. The command line is fast and precise once you have learned it, uses very few system resources, and is easy to automate with scripts and repeat exactly. But it has a steep learning curve, and one typing slip can cause an error. The graphical interface is intuitive and welcoming for beginners, shows you your options visually so there is less to memorize, and is lovely for creative and everyday tasks, though it uses more memory and processing power and is slower for repetitive, bulk jobs. So when would you reach for each one? The graphical interface suits everyday users, browsing, writing, design, general office work. The command line suits system administrators, developers, and servers, where speed, automation, and remote control really matter. And in fact, many servers run with no graphical interface at all to save resources. Picture renaming 500 files at once. That is a single command line instruction, but a long, error-prone slog of clicking in a graphical interface. Neither is simply better. It depends on the user, the task, and the setting. Let us watch one task done both ways, copying a file. In the graphical interface, you open File Explorer and drag the file into the new folder, or right-click and choose Copy, then Paste. In the command line, you type a single instruction, something like copyreport.docx to drive D and press Enter. Both end up with the file copied. The command line is quicker to repeat and script, while the graphical way is easier to learn in the first place. Beyond those two, there are a few interface styles worth knowing. The graphical interface gives you windows, icons, menus, and a pointer, like the Windows or macOS desktop. The command line takes typed text commands, like the Linux terminal. A menu-driven interface has you pick from lists, like a cash machine or a ticket kiosk. And a natural or touch interface uses voice or touch, like a smartphone screen or a voice assistant answering when you speak to it. Think about a family sharing one laptop for homework, photos, streaming, and a bit of online shopping. None of them are technical, so the graphical interface is perfect. They click icons instead of learning commands. They open a browser, a word processor, and a photo app just by pointing and clicking, and dragging holiday snaps into folders is simple and visual. Here, the graphical interface is clearly the right call, intuitive and forgiving. A command line would only slow these everyday jobs down. Let us pull Learning Outcome 2 together. Software is the programs that control the hardware, split into systems software and application software. Operating systems, single-user, multi-user, real-time and mobile, manage the processor, memory, files and devices, while utilities keep the machine healthy and applications, general purpose, specialist or bespoke, do the work you want. Software can be proprietary and paid or open source and free, with the choice resting on cost, compatibility, support and features. And a command line uses typed commands and suits automation and servers, while a graphical interface uses point and click and suits everyday users. So that wraps up our tour of software, from operating systems and utilities to the choice between proprietary and open source, and the two ways of controlling a machine. If you want to dig deeper, the reading points you towards classic operating systems texts by authors like Silberschatz and Tannenbaum, and towards Microsoft Learn and the open source initiative for the practical and licensing side. There are also two rather telling case studies. Munich's Linux move into and back out of open source, and GIMP against Photoshop as open source versus proprietary. Have an explore, and keep in mind that the assessment wants both the differences and the uses of each interface.